Hello, everybody, and welcome back to my channel.
Cat! How many times do I have to tell you we are not YouTubers? We are trying to make an educational math lesson here.
Well, at least we can edit that part out, Crystal. We can just pretend she didn't do that.
Well, joke's on y'all. I'm the one editing this video, and I will actually not edit it out. Y'all just are jealous of my fame. So actually, one of these days, you're going to be grateful that I didn't edit you guys out of my video. You're welcome.
Anyway, it's time to teach math. So without further ado, let's get on with it.
Hopefully, this will gain Kat all the subscribers that she rightfully has earned.
Okay, Kat, let's move on to the slide.
Fine, we'll do the boring stuff. Whatever. Okay, so what did the triangle say to the circle?
I don't know, Kat. What?
You're pointless.
So, welcome to our Team Teach lesson number 3 with the smarticle particles.
Today, we're going to be learning about length, area, and volume.
Guiding you through this will be myself, Kat Knight,
Crystal Lambert,
and myself, Laura Wynn. By the end of today's lesson, we will have conquered the Romans and made Greece our own. Just kidding. We will have conquered more math, but this time with shapes, area, and perimeter.
Okay, so, can anyone explain what the doubling system of the capacity of measurement is?
I can, Kat. I'll help you with that. So, what is the first thing that you think of when you hear the word doubling?
Multiplying by 2?
Yes. So, when we hear the word double, we automatically think times 2. And that is essentially what's happening here. We're going to look at each unit of measure, and it has 2 of a different unit inside of that unit. So let's begin with the pail. 1 pail is equal to 2 gallons. And when we think gallon, we think of milk, right? So that's why we're looking at a gallon of milk. And then, so what about a gallon? What goes into a gallon? Well, 1 gallon is equivalent to 2 bottles. Okay, so from there we have 1 bottle. What goes into a bottle? Well, 2 quarts goes into 1 bottle. And here, what do we normally think of when we think of quarts? We think of oil, because that's pretty much one of the few things we buy in quarts. So we look at 1 quart, and what is 1 quart? Well, 1 quart is equal to Ben and Jerry's. It's 2 pints. So what is 1 pint of Ben and Jerry's? Well, it's actually 2 cups. And then from 2 cups, what is in 1 cup? Well, 1 cup is actually equal to 2 gills. And gills is not something we hear every day, right? I don't walk around and say, I need a gill of something. No, that's Old English. So that's where that comes from. So when we're looking at a gill, 1 gill is actually equivalent to 2 jacks. And know that when we say equivalent, that is a fancy way of saying equals to. So 2 jacks is equal to a gill. Well, what is a jack? A jack is actually 2 jiggers. Do you know what a jigger is? Well, you've probably heard other people say a shot. They want a shot of something. A jigger is a shot. So 1 jigger. What is 1 jigger? Well, 1 jigger is equal to 2 mouthfuls. So next, we're going to have Miss Laura see if she can help us with something. Laura, how would you show us the number of mouthfuls in a gill?
That's a very good question, Crystal. All right, from your breakdown of equivalents, we know that in 1 gill, there'll be 2 jacks. So using the doubling system, we can figure out that there are 2 jacks and 4 jiggers. And 4 jiggers, there are going to be 8 mouthfuls.
So how many mouthfuls are in a Jill?
So there's going to be 8 mouthfuls in one Jill. Crystal, can you show us how to figure out how many mouthfuls are in a cup?
Sure. Hey, Kat.
Yes,
A
Crystal?
cup has 2 of something in it. Do you remember what it is?
Is it Jill's?
You are right. Good job, Kat. There are 2 Jills in a cup. Now, think back to what Laura taught us. If we use what we discussed with Laura, we know that there are 4 Jacks. Well, there's 2 Jills in our cup, and there are 4 Jacks in 2 Jills, and there are 8 jiggers in 2 Jacks. No, 8. Whoa, I just confused us all up. Let's break it down really easy. So in one cup, there are 2 Jills and 4 Jacks and 8 jiggers and 16 mouthfuls. How about that?
All right, so we're going to figure out how many mouthfuls are in a pint. So we know that 1 pint is equal to 2 cups. So let's break it down even more. 2 cups are going to be equal to 4 Jills. 4 Jills is 8 Jacks, 16 jiggers, and finally 16 jiggers equal 32 mouthfuls. Kat, can you help us fill up this bucket using everything we just learned?
Yes. So we're going to fill up a pail, and to start us off, I went ahead and put everything that Laura and Crystal did into a beautiful little chart because we are going to reference back to this when we were filling up our pail.
So what is the point in putting them in the same measurements, Kat?
Well, we know that mouthfuls is the absolute smallest measurement that we have. So we know that each one of these units has at least 1 mouthful in it. So that's really the only one that they can all be converted into. And that way, we can easily put them all together and add them up. So here's our pail, and we're going to go ahead and fill it up. We're going to start with our biggest first, which is a gallon. There's 512 in this, which in the pail, mouthfuls. So we're going to go ahead and fill it up with our gallon, and that is 256. So now we're going to go ahead and fill it up with everything else that we have, 1 of everything. So let's go ahead and fill our pail up. Ignore the numbers, pretend that Kat made a perfect animation. And so to find the next line, we're going to go ahead and add 128, which is our bottle, to 256. And when we do that, we get 384. Then we're going to go ahead and add 64 to that, which is our quart, and we're going to get 448. And we're going to continue this pattern all the way up until we get 511. So the question asks is how many more mouthfuls can we put in there without it overflowing? We can put 1 more in there to keep it completely even, but if we put anything else, it will overflow.
Okay, so next we're given triangles, and we're asked to find the area and the perimeter of our triangles.
How do you know the area and perimeter of a triangle, Crystal?
Well, we use the formula for area of A, which stands for area, equals 1/2 base times height, or 1/2 B times H. Then we will use the area for perimeter. We will use the formula P for perimeter is equal to A plus B plus C. And A, B, and C are all sides of our triangle.
All right, Crystal, how do you know what to use for the height?
So our height is the point that makes a right angle. So if you notice here in our triangle, there is 1 line that meets the base that forms a right angle or a 90-degree angle. So that is the measurement we're going to use, is the measurement of that line. So here we're going to go on and we're going to input this into our formula for area. And we're going to use A equals 1/2 times 82.3 meters. Do not forget your units of measurement, times 41 meters. And when we do this, we're going to get a total of A equals 1,687.15 meters squared. Do not forget to square your meters, because when you multiply meter times meter, you get meters squared. Now next, we're going to go ahead and look and find our perimeter. So we're going to add the 3 sides. So when you think perimeter, think of the outside edges of something or the length. Think security guards walk the perimeter. It's the outside where you would put a fence. So here we look at our fence line of our triangle, and we have P equals 82.3 plus 48 plus 69, and that gives us a perimeter of P is equal to 199.3 meters. And in this instance, we do not square it because we just added. And when you add measurements, you just continue with the same measurement.
All right, so again, this problem, we're going to do the area of a triangle, and we're going to find its perimeter. So here's the triangle it gives us.
So Laura, what type of triangle is that?
Well, that's a good question, Crystal. This is actually a right triangle, and you can tell.
How do you know it's a right triangle?
Because the little box right there lets you know that it makes a 90-degree angle, so it makes it a right triangle.
Thank you.
So we're going to use the formula that Crystal had told us. Area is equal to 1/2 base times height to solve the area of the triangle. So we're going to plug in our numbers. The base is...
Well, Laura seems to have frozen. Is she back? She's back.
Yay!
Yay! Welcome back.
All right, so the area is going to equal to 1,642.8 inches squared. Now to find our perimeter, we're going to add all the lengths of the sides together. So we're going to do 88.8 plus 37 plus 96.2, which is going to give us 222 inches.
Okay, so again, we're going to find the area and perimeter of a triangle, and we're going to use the formulas that we have been using the whole time. Just 1/2 base height.
Well, Kat, I have a question. So where does this 1/2 come from in our formula?
I'm actually glad you asked. Let me visually show you, since I'm a visual person. I'm using some pretty pictures, and we're going to figure this out. So here we have a rectangle. A rectangle, we're doing triangles. Hold on, I'll get there, I promise. So we all know that rectangles are simply just the length times the width. That's pretty cut and shoot, simple, straightforward. We got that. So what if we cut our rectangle in half? Diagonally. What is it going to look like? Looky there, we've got 2 triangles. So when you cut this rectangle in half, it is going to give us 2 separate triangles. So 1/2 of that would be 1/2 base height. Make sense?
Yes.
Okay, so now we're going to continue. Here is our next triangle. So our height is actually this 2.6. We're going to ignore this dashed line. It's just there to aid us in visualizing a right triangle. So we're going to go ahead and plug in our numbers. 1/2 base times height, which I forgot to put the 1/2 right here, so we're just going to pretend that it's there. So 1/2 times 6.2 plus 2.6 equals 8.2 centimeters squared. Perimeter, once again, we're just going to simply add up all of our sides. So we're going to ignore this 2.6. We don't need it now. It's irrelevant. So we're going to do 3.1, 6.2, and 8.5. We're going to get 17.8 centimeters.
Okay, so in our next problem, we're given a square that is inscribed in a circle and circumscribed around another circle.
What does inscribed mean, Crystal?
Well, listen to the word inscribed. Does it make you think of anything? When I hear inscribed, I hear the prefix in. So inscribed would mean that the square is inside of the circle.
Well, what does it mean when you say that the square is circumscribed in another circle?
So when I hear circumscribed, I hear circle, right? And the circle goes around something. So as you can see in this illustration, that the square is actually on the outside of the circle, as shown right now. So when we say a square circumscribed another circle, that means the square in this instance is surrounding the circle.
All right, so now we're going to find the area of the smaller circle. In order to do that, we're going to use our formula of a circle, which is pi r squared. And
What? Oh, sorry. How do you know what the radius is?
well, in this problem, it gives us that the length of the square side is 10 units. And when you put that line across the smaller circle, the radius is half of the diameter of the circle, which will give it 5 units. So we're going to plug that information into our formula for an area of a circle, and that's going to give us 25 pi units squared.
Okay, so we're going to use the same shape, and now we're going to try to find the distance between the two circles. So here I have cut the square in half diagonally, and again, just to go ahead and so we can see our triangle, I have drawn the radius out again of the smaller circle, and we know that that's going to be 5.
So why are we using triangles to find the radius of circles?
Well, so we have triangles, right triangles, a square can easily be turned into right triangles. And right triangles have the beautiful, lovely Pythagorean theorem that everybody loves. You know what I mean. And so we're going to go ahead and use the Pythagorean theorem to find this missing length of this triangle. And the missing length of the triangle is very important because that's the radius of our bigger circle. So we're going to go ahead and use our Pythagorean theorem and plug in our numbers, which is 5 squared plus 5 squared. I went ahead and wrote 25 equals r squared. And I'm going to cheese it a little bit and say 50 equals r squared because I know that r squared is going to be within that formula that we are needing to find our radius. So we get our area equals 50 pi units squared. But we're not done because we're trying to find out which is bigger, the area of the circle or the distance between the smaller circle and the bigger circle. So I'm going to go ahead and subtract 50 pi units from 25 pi units and get 25. So it's actually equivalent.
All right, so with this shape that is given to us, we're going to pull out the circular cylinder cone from inside of it to find the volume of the cone. Here's the information it gives us.
Laura, I have a quick question.
Mm-hmm.
So how do you know what formula you're going to use for the base?
Okay, well, if you look at our cone, Crystal, you see that the base of our cone is actually a circular shape. You're going to use the circle, the area of a circle, to find that formula. All right, so our volume of the cone, okay, so the volume is 1/3 base times height. And then our base is the area of a circle, pi radius squared. And we're going to plug in the radius and the height that they have given us over here into our formula. So 1/3 pi r squared times 2r will give us our volume of a cone, which is 2/3 pi r cubed.
Okay. So on our next step of this problem, we're wanting to find the volume of a cylinder. So to find the volume of our cylinder, you're going to use the formula V, or volume, equals big B times H.
Crystal, what does big B mean?
Okay, so the big B here is the base area. So we have to, in order to figure out the volume, we have to know what that area of the base is. So we're going to plug in the formula for the area of the base into our original problem. And that's going to give us volume, or V, equals pi times r squared in parentheses, right? Because that's going to be one number when we plug in real numbers, times 2r. And then that's going to give us V equals 2 pi r cubed. Next, we're looking at the sphere. And when you think sphere, think of an orange or a ball. You know, it's circular all the way around. And then once again, like our cylinder we just talked about, when you think cylinder, think of a can. So back to our sphere. Our sphere has an formula of V equals 4/3 times pi times r cubed.
Okay, so now that we have this funky shape where we've got an orange and an ice cream cone inside a pecan.
A pecan? Do you mean a pecan? What does that have to do with math?
No, a pecan, like a can of peas. You silly cylinder.
Oh, okay.
Anyways,
Scare me, Cat.
so we are going to go ahead and fill in our little chart that I have written out here with the information that Crystal and Laura have given us. So here's our formula of a cone, our formula of a cylinder, and our formula of a sphere. And now we're going to divide the cone into each one of the other shapes.
So why are we using the cone as one instead of any of the other two?
The cone has the smallest unit of measurement, or the smallest volume of the other two. And just like if you recall from our mouthfuls problem, we know that since it's the smallest, it can fit into each of the other ones at least one time, so it has to be the one that is 1. So we're going to make our cone 1, and then when we divide our cylinder by the formula of the cone, we get 2. And we divide our sphere by the formula of the cone, we get 3.
Okay, so now we're going to have to find the surface area of this right trapezoidal prism. To do that, you need the surface area formula, and I have my formula color-coded and my shape color-coded. So the surface area is 2b plus pH. All the green numbers is the base, the yellow number is the height, and the perimeter you add up all the sides without including the height. So you plug your numbers into your formula, like I've done here. You work out your problem, and it's going to give you the answer. You're going to solve it, which is going to be the surface area of this right trapezoidal prism is going to be 796 centimeters cubed.
Okay, so again, we're going to do the same thing. We're going to go ahead and find our surface area, but this time it is a triangular prism.
So, Kat, how do I know what the base is?
Okay, so this shape is 3-dimensional. So think of what you think of. So what do you think of when you think of 3-dimensional? I just said think like 9 times in one sentence, but you know what I mean. When you're watching a 3D movie and something pops out at you, that's what makes it 3D. You feel like you can reach out and grab it. Well, if you look here, the triangle is what looks like you can reach out and grab. Everything else is just added to give that triangle more dimension, which makes this 3-dimensional. So that's how we know that our triangle would be our base. So now I have went ahead and outlined our base, which is the triangle, and the yellow is going to play as our perimeter, and then the pink is our height. So I too have color-coded my formula just like Laura, and then we're going to go ahead and plug in our numbers. So our base, because this is a triangle, we have to do our triangular formula. We're going to get 28. Our perimeter is going to be 40. And then when we go ahead and plug all these numbers into our formula, we get 336 meters squared.
All right, so from the shape given to us, we can see that there's a cone and a cylinder.
We use the area of the cone, and since the base is circular, we also use the area of a circle. Then we use the formula for the area of the lateral cylinder.
There's our beautiful cone and our cylinder. And the
Yay! So the area of our cone is S equals pi RS. And then we have that circular circle for base is S equals pi R squared. And our lateral area of our cylinder is S equals 2 pi R H, which is 2 times pi times radius times height.
Very good. All right, to find the surface area of this object shape that they've given us, you're simply going to add up all those formulas together, like we've done here.
Where does the S come from in that formula?
S actually stands for the slant length of the triangle over here. The 6M is actually the slant length of the triangle. So we're going to plug in all the information that's given to us into our lovely formula, and we're going to solve it. So it's approximately 176 meters square is the surface area of our object. So now we got to find the volume. Here's our volume formula, and if you notice, there's an H1 and an H2. Well, the height is already given to us, is the 10 meters is our height, but to find H2, you need to use the wonderful Pythagorean theorem, which we have done over here, where you plug in the slant length and the base of the triangle, which is 2, you square them, you get approximately 5.66. Now you can plug everything into the lovely volume formula, and you get approximately 149 meters cubed.
Okay, so now for this shape, you can tell that we have a sphere and a cylinder. We're going to do our formulas to find those.
So a sphere is a round ball-looking shape, and I don't see that on your shape that you're explaining. Are you off your rocker, or where is the sphere?
Okay, so the beautiful thing about shapes is we can manipulate them as we want to, like men. Just kidding.
Good luck.
So we can manipulate the shape as long as we're not changing any of the measurements. So if we see here, this is half of a sphere and this is half of a sphere. So we're going to put them together and we're going to get a whole sphere. Oh my God. And then we just got our cylinder. So now I'm going to do it a little bit differently than Laura did. Instead of just putting all the formulas together, I'm going to go ahead and find the surface area of the sphere and then find the surface area of the cylinder and then add those together. And it works either way. You can do whichever one you want to. I just did this to show you that there is more ways than one to do it. So here we have our surface area of our sphere, which is 4 pi r squared. So I plugged in our numbers and get 64 pi feet squared. Anyway, so now we're going to do the same thing to the cylinder, plug in our numbers, and we end up with 168 pi feet squared. And when we add those together, we get 232 pi feet squared. And now we're going to do the volume. I'm going to do the same thing, but this time we're just going to use the formula for volume. So when we plug this one in, we get 84.3 pi feet cubed. I'm going to do the same thing over here. I'm going to get 336 pi feet cubed. I'm going to add those together, and we're going to get 421 pi feet cubed. So that is all I have for y'all. So make sure to like and subscribe to my channel. And we will see you next time. Thanks for watching.
Thank you.
Bye.